Hello, class. Okay, let's continue our topic. So we stopped here. Just a quick review. Last meeting we discussed about real gases. We discussed these terms: critical point, critical state, and the compressibility factor Z, which is a deviation from ideal gas behavior. And then last meeting we also discussed uh, the compressibility charts. Okay, this compressibility charts. And, ano ba yung na-observe natin dito? Okay. Na-observe natin na when gases are in their normalized temperature and pressure, okay, they behave the same. That's why in this compressibility chart, diba, the different symbols here, okay, would point out to different gases. And then may patterns silang nakuha at certain TRs and PR. So, meaning, for this TR here, which is this line, at different, nag-follow siya ng the different gases, okay, follow this line here at different PRs. Okay, at a certain TR equal to 2. Okay, so ganun din, at different TR, say TR equal to 1.5, these different gases followed this line, this pattern, at different PRs or reduced pressure. And the Z factor, okay, or the compressibility factor for all gases is approximately the same at the same reduced pressure and reduced temperature, which is the scientists named that the principle of corresponding states. So this is a zoomed in figure of the compressibility chart. As you can see here, the reduced pressure is from 0 to 1. Zooming out a bit, uh, meron na siyang ganitong shape, okay? And this is from reduced pressure 0 to reduced pressure 7. And further zooming out, okay, this is the compressibility chart. So, ito na siya from reduced pressure 0 to reduced pressure 40. Anong ma-observe natin? Okay? At low pressures, meaning the PR is significantly less than 1, the gas behaves as an ideal gas regardless of the temperature. So, alin ba dito? Yung um, part na reduced pressure. Okay, so reduced pressure low reduced pressure. So, dito yon sa area na to, 'di ba? This is the area of reduced pressure. And we have, of course, different reduced temperatures. But regardless of the reduced temperature, the, the behavior of the gas is like an ideal gas. So, how can we say that it's like an ideal gas? Malapit, if not 1, okay, diba? Ito, at reduced pressure na low, which is itong part na to sa corner ng figure, diba? Reduced pressure 0 to, say, mga low reduced pressure, diba? Ano siya, at 1. Okay. So, ito yun pala. Ang sabi niya kasi is less than 1. So, if yung 1 ay ito, okay, at this point on the figure, so ito yun. Let's zoom in. Okay. Let's use the zoom in. So, ito yun. Okay. Reduced pressure is less than 1. So, ito ay 0.1, 0.2, 0.3. And then we have various TRs. Okay. So, ang sabi naman niya is less than 1. So, let's assume na ano siya, mga point 0, between 0 to mga point 1 lang or point 2. So, malapit siya. Okay. Malapit siya sa value ng compressibility factor na nasa y-axis, malapit siya sa value na 1. So, regardless kung ano yung TR niya, so the TR are represented by the different lines here. 'Di ba? Pag less than 1 ang PR mo, which is itong part na to, okay, malapit lang siya sa z equal to 1. So, that's the observation 1. The first observation. The next observation is at high temperatures, meaning the TR is greater than 2. Ideal gas behavior can be assumed with good accuracy regardless of the pressure. So, pag yung TR ay greater than 2, malapit pa, ano pa rin siya, it behaves like an ideal gas regardless of the pressure, except when the pressure is pag dalawang sign, greater than 1. Okay, let's see. Asan ba yon yung mga TR na greater than 2? Okay, TR na greater than 2 dito sa compressibility chart natin. Ito sila. So, this is the line. So, i-zoom in ko lang muna. Okay, so i-zoom in ko lang muna. This is the line TR na equal to 2. So, pag greater than 2 raw yung TR, it behaves like an ideal gas, which is true kasi this is the line na z equal to 1, diba? Yun. So, ito siya. So, ito naman yung less zoom out version. This is the line TR equal to 2. So, yung PR mo ay hanggang dito sa part na to, PR mo equal to 3, malapit pa rin siya sa Z equal to 1. Pero, yung PR equal to 7, P meaning reduced pressure na equal to 7, this is the part, nagde-deviate na siya. Okay, sa 1, sa line Z equal to 1. Okay? So, that's the second observation. And the third observation is that the deviation of a gas from ideality is greater in the vicinity of the critical point. So, paano ba natin malalaman sa reduced temperature and reduced pressure na siya, critical siya. Malapit sa critical point. So, remember ang equation ng ng reduced temperature and reduced pressure ay reduced temperature is the T over T critical. Diba? And the reduced pressure is PR equal to P over P critical. So, pag malapit siya sa reduced temperature or malapit siya sa reduced pressure, so yung TR mo ay malapit sa 1. And yung PR mo ay malapit sa 1. Okay? Kasi mag-i-equal tong dalawa. Tong dalawa. Okay? Kaya magiging equal to 1 yan. So, pag yung TR at yung PR equal to 1, as in, sila pareho ha, dapat true yun, TR and PR equal to 1. Ayan, so puntahan natin, alin ba siya dito? Ito siya. Yung value na to, PR equal to 1, sige dito sa isa. Ito, PR. Yan. PR equal to 1, TR equal to 1. Kita nyo, andito siya. Ang layo niya sa Z equal to 1. Okay? So, ibig sabihin nga, the deviation is great at the critical temperature and critical pressure. Okay? So now we are ready to answer this problem. Mhm. Sige, let's try this problem. Determine the specific volume of refrigerant 134-A at 1 megapascal and 50 degrees Celsius using the ideal gas equation and the generalized compressibility chart following. So, binigay na yung data ng critical pressure and temperature for refrigerant 134-A. Binigay na rin yung R na gagamitin. Compare the values obtained to the actual value, which this is the actual specific volume of the refrigerant, and determine the error involved in each case. Okay, let's solve the problem. Okay, I will not anymore write the given. So, okay, fine, sige. Let's write the given. Okay. Oops. Let's write the given. Okay. Refrigerant 134-A. The pressure is 1 megapascal and the temperature is 50 degrees Celsius. The critical pressure is 4.067 megapascal. The critical temperature is 374.3 Kelvin. So, gamitin daw na yung R na equal to 0.0815 kilopascal meter cube per kilogram Kelvin. Pardon my handwriting. Okay. I'm still adjusting to this pen. So, ang required ay what's the required? Specific volume if we assume na ideal gas. And also, the specific volume if based sa compressibility chart. Using the compressibility chart or the Z factor. And we need to compare with the actual na equal to 0.0217 meter cube per kilogram. Okay? So, for letter A, let's use for the specific volume na ideal gas. Obviously, we must use the ideal gas equation where V is specific volume. Okay, so isolating yung V on one side of the equation gives us this equation. Then, substitute the value of R per kilogram Kelvin. Okay. 0.0 kilopascal pala siya. And then, temperature na 50 degrees plus 273.15 Kelvin. So, sa ilalim, yung pressure, Okay, pressure na 1 megapascal and that is equal to ilan? 1,000 kilopascals. Okay, cancel out. Cancel out. Ang matitira ay meter cube na unit ay meter cube per kilogram. Okay? So, the answer is 0.02633 meter cube per kilogram. Okay. So, now we compare with the actual volume. Wait lang. So, let's get the percent error. Yung percent error, diba, what's the equation of the percent error? The VIG minus V actual over V actual times 100. Okay, diba? So, the VIG or V sa ideal gas na nakuha natin is 0.02633. Mamaya na yung unit. Yung given na V actual, ito. This is the given V actual. This one. Okay. 0.02171. Okay, divided by the actual 0.02171 times 100, you get 0.2, ay, mali. Wait lang, mali. Eraser. Eraser. Ba't ang liit ng eraser? Ito. Ang liit pa din. Yan. Okay, so, the answer is 21. 21.3%. Ito. So, these are the answers for letter A. Okay? Now, let's try letter B. Oops. Let's try letter B. Lakihan ko lang tong letter B. This time, we are going to use compressibility charts. Okay, compressibility charts. Okay, so let's try. For letter B, before we can use compressibility charts, we have to compute for the reduced pressure. So that is P over PC. So that's 1 megapascal, diba? 1 megapascal over the given 4.067 megapascal critical pressure of refrigerant 134-A equal to 0.246. So that's the the reduced pressure. For the reduced temperature, diba, it's the given 50 degrees Celsius plus 273.15 divided by the given critical temperature. So, the reduced pressure is 0.863. Okay. So, using these values, yan, Let's read the Z from the compressibility chart. Okay. Anong value? 0.246 siya, 0.863. So, gamitin natin yung zoom in version. 0.246 na PR. So, banda rito yun, diba? And then, 0.863 na TR. OMG! Nasaan yung 0.8? 0.863. Ito. This is 0.85. So, ito yung 0.86789. So, manghuhula tayo. At saka, 0.246. So, 0.246 na, so, banda nga rito yun. 0.25. So, round off natin, 0.25. At saka, 0.86. So, marang malapit lang sa 0.85. So, at this point yon, so, papatamain natin dito sa y-axis. And that's about a little lower than 0.85. So, it's about 0.84. 0.84. Okay? Now, let's use that to solve for, diba, ano bang equation ng V using compressibility chart? It's V times V IG, diba? So, 0.84 times yung nakuha nating VIG from letter A, 0.02633 meter cube per kilogram. So, times 0.84 yun. The answer is 0.02211 meter cube per kilogram. So, now let's check the percent error. Okay, the percent error is yung V from the compressibility chart minus V actual from experimental data, which is the most accurate, diba? V actual times 100. What you will get there, substituting the values, the percent error is only about 1.87%. So, comparing, diba, comparing with the percent error na 21.3% na ideal gas, when you use the compressibility chart, mas accurate siya. So, mas predict niya yung behavior ng real gas. Okay. Kasi ang laki ng 21%, diba? As compared to 1.87%. So, that's one way we can solve for the properties of real gases by using compressibility charts. Okay? Let's have another example. Where are you? Other example. So determination of pressure of a gas using generalized compressibility chart. Ito muna. Determine the pressure of water vapor at 600 degrees Fahrenheit and specific volume. So, ang given ay temperature at specific volume using the steam tables, the ideal gas equation, and the generalized compressibility chart. So, save ko to. Try 142 sa lectures part to this is sample problem. Okay. So, na-save ko na yan. Control nyo. Gusto ko yung size ay malaking malaki. Yan. Okay. Yan. Solve natin. The given ay temperature equal to 600 degrees Fahrenheit. V is 0.51431 feet cube. So, 1 yun 1 per pound mass. Okay, erase. And then, required, okay, that P from steam tables. So, gawin kong ST pag steam tables. B, ideal gas. C, P from Z charts. Okay? Okay, so given for water, okay, diba? Water vapor. Let's use yung PC na given 3,200 PSIA and TC 164.8 Rankine. And let's use the R na 0.5956 PSIA feet cube per pound Rankine. Pardon my handwriting, ha? So, letter A, using steam tables. So, saan ba makikita yung steam tables? Meron sa internet and meron din sa reference natin na si Smith and Van Ness. Okay, so from Smith and Van Ness, go to Appendix E. So, 8th edition to, steam tables. So, hanapin natin, since water vapor siya, okay, it's the saturated steam table. So, rotate, ayan, saturated steam tables. Pero ito kasi ay SI unit. So, hanapin natin yung English units. English units kasi tayo. Wala siyang English units. Talaga ba? Wala siyang English. Wala siyang English units. OMG. So, anyway, do sa 7th edition ng steam table, meron siya. At saka, pwedeng i-check nyo sa internet kung anong value. Pero, the value, okay, so this is from experimental data. The value of P, actual, kasi nga, experimental data ang steam tables is 1,000 PSIA. So, this is P actual. Hindi ko lang nalagyan ng label. It's the P actual. Okay? So, letter B, using ideal gas, P is equal to RT over V. Let's substitute the values. 0.5956 PSIA per feet cube pound Rankine. Okay? And then, multiply that with the given um, given temperature na 600 Fahrenheit plus 460 para maging Rankine. Absolute tayo, absolute temperature. Divided by the given specific volume na 0.51431 feet cube per pound mass. Okay, so cancel yung pound mass, cancel yung Rankine, cancel yung feet cube. We're left with PSIA. The answer, this is PIG. For PIG is 1228 PSIA. Okay? Now, let's calculate for the percent error. Okay? Which is PIG minus P actual over P. And that is 1228 minus 1000 over 1000 times 100. So, this is times 100 pa. Okay. This is percent error 22.8%. Ay! Yun. Control Z pala ang technique. Okay. So, that's letter C. I mean, letter B. Now, let's use yung Z chart. So, if we want to use yung Z chart, we first need to calculate for the pseudo reduced specific volume and reduced temperature. So, paano makakalculate yung pseudo reduced specific volume? So, letter C, pseudo reduced volume, we use this equation, yung V actual, diba? And, supposedly, this is V critical, V actual, na given sa atin, we can use this for V critical. Okay, so para siya yung ideal gas equation, pero use the critical temp and critical pressure. So, let's substitute the value. So, this is given, yung V actual, feet cube per pound mass. Okay. Divided by yung R, PSIA feet cube per pound mass Rankine times the critical temperature na given. Okay, critical temperature na given ay 1 divided by the critical pressure na given. PSIA. Okay, feet cube. So, tama. It's unitless. So, VR is 2.73. Oops! 2.372. And then, yung TR is T over TC. And that is yung 1060 Rankine, diba? 600 plus 460 times, divided by the given critical temperature, okay, 0.91. Tanong, pwede ba natin gamitin yung compressibility chart na ginamit natin kanina na nung nagbasa tayo ng mga temperature and pressure na SI unit? Of course, we can kasi unitless. Okay, ang PR and TR doesn't matter if nagsimula yung temperature mo ng English or SI. Kung TR, PR na yan, pwede mo pa rin gamitin. So, the VR is 2.372, tas TR na 0.91. So, meron dito kasing lines ng VR. Okay? Kung may lines ng VR, nasa na yung 2.372 dyan. Ito yung 2.4, ito yung 2.2. So, malapit sa 2.4. So, ito yon. Zoom in ko lang. Okay, kita nyo na. This is the VR. Kaya ako nalaman na yung line na ganyan ay VR kasi meron ditong label. Ito, VR. So, lahat nung dash line na ganun, pag ganun ng direction, VR yan. So, ito yung 2.4. And then, yung TR mo na 0.91, nasa na yun? Ito yung 0.91 na TR. So, kung saan sila magbabangga. 2.37, so medyo baba nung 2.4. Tapos 0.91, medyo taas nung 0.90. Okay, so itong point na yon, babasahin mo yung Z. So, sa banda ron, hindi pala. Ang babasahin mo ay P. Kasi ang kailangan mo ay yung P value ulit. So, PR. So, ulit, 0.237 na TR, tsaka na VR, at 0.91 na TR. Okay, so ito yung point na yun. So, bababa tayo, pababa. Kasi nasa x-axis. Ay, nako, naputol na. So, kailangan ko mag-zoom out. Ito yun. Point. Dito sa banda yun, pababa. So, ano siya parang 0.33 yung PR. So, yung PR from the Z chart ay about 0.33. Now, calculating the P, diba, is PR times PC. So, that's 0.33 times yung critical pressure given. It's 1056 PSIA. So, yeah. Okay. So, let's solve for the percent error. Percent error, diba, it's the P. So, let's say, ang tawag natin dito ay yung P na galing sa Z. P actual na 1,000 from the steam table times 100. So, that's 1056 minus 1,000 over 1,000 times 100, 5.6%. Ano masasabi nyo ngayon? Compared naman dun sa ideal gas na 22%, 5.6, mas acceptable yung 5.6%, diba? So, this is sample problem 2. Okay? Okay, so hanggang dito na muna yung lesson natin. Medyo mahaba na. Sige, ano ba yung next dito? Mag-move on na tayo sa next topic, which is yung equations of state na alam nyo na from Phychem, 'di ba? Okay, so bye for now.